Hello everybody. So we are now starting a new topic, that is water and its treatment, which comes under Unit 1B of Engineering Chemistry. Now the contents under this unit are, first we will be defining what is the hardness, what are the causes of hardness, what are the types of hardness, and how we are going to measure the hardness in water. Now next topic is what are the different types of boiler problems, like the sludges, the scales, caustic embrittlement. They are some of the troubles that are encountered in a boiler because of the use of hard water. Now softening of water, we'll be dealing under the lime soda process, the zeolite process, the reverse osmosis process, ion exchange process, and the Calgon process. Now next will be the introduction to the membrane concept for treatment of microplastics from water, and finally we'll be dealing with the numerical problems based on the lime soda process, the zeolite process, and the hardness of water. Now the course outcome is to understand the chemistry of purification of water and its industrial and domestic applications. Now, how will we define hard water? Now, we know that the water that does not form lather with soap very readily is known as hard water. In fact, because of the presence of certain salts, the hard water will form a white scum or a white mass. Now, that type of water is called as hard water. So, in other words, we can define hard water as the soap consuming capacity of water. So, that means if the soap consuming capacity of water is very high, so that means the hardness is very high. Now why the hard water is consuming a lot amount of soap? Now first of all, let me tell you that hardness is because of the presence of salts of metals, the metal ions like the calcium ions, the magnesium ions, the aluminium ions, the ferric ions or the ferrous ions, then the manganese ions. Now if the salts of such ions are dissolved in water, so that means such water will not form lather with soap very readily. Now let us see now why the hard water is consuming a lot amount of soap. Now if the hard water is containing these metal ions or the salts of these metal ions, then such metal salts, they react with the soap. Now what is soap? Soap is nothing but the sodium or the potassium salt of oleic acid, palmitic acid, stearic acid. Now all these are higher fatty acids. Now when soap is added to this hard water, then such metal ions, they react with this sodium or potassium salt of the higher fatty acids to form insoluble precipitates which appear as white mass or white scum on the internal parts of the container in which the hard water is placed. So let us see the chemical reactions that are involved. Now calcium chloride, magnesium sulfate, they are taken as examples of the hardness producing salts, and this is the sodium salt of oleic acid, and when this calcium chloride is reacting with this higher fatty acid, then it is formed calcium salt of the oleic acid. Now similarly magnesium salt, when it is reacting with the sodium salt of the oleic acid, it is forming the magnesium salt of the oleic acid. Now the calcium and the magnesium salt of the oleic acid, they are precipitates, whereas the sodium salt of oleic acids, they are not precipitates, they dissolve in water. But if such hardness causing salts are present, then the calcium and magnesium salt of the oleic acid that is formed, now that will form as a white precipitate, which does not allow the soap action. That means the action of soap is depressed because of this. So what is the difference between the hard water and the soft water? The hard water is, as I said, that it does not form lather with soap readily, but it forms a white mass. Now such type of water is called as the hard water. Now soft water is that which easily lathers with soap, is called as soft water. Now the presence of calcium and magnesium salts in water results in the hard water, whereas the absence of calcium and magnesium salt in water leads to soft water. Now what are the consequences of using hard water is that more amount of soap or detergent is consumed because of the depressed cleansing and detergent action. Now also the hard water, it causes the elevated boiling point, because we know that the presence of impurities results in the elevation of boiling point. So that means if we use hard water for cooking, what happens is that it results in more consumption of energy and time. Now, whereas in the case of soft water, the soft water does not result in wastage of soap. The cleansing action is enhanced, and also it does not result in the wastage of fuel and time during cooking because of the absence of calcium and magnesium salts. Now, let us classify the hard water. We know that hard water are classified into two types. One is the temporary hardness, the other is the permanent hardness. Now, the temporary hardness is because of the presence of the bicarbonates of calcium, magnesium, and other heavy metals like the carbonates of iron, and it is also called as the carbonate hardness or the alkaline hardness. Now, alkaline hardness is because of the presence of the bicarbonates, the carbonates, and the hydroxides of the hardness producing metal ions. We know that alkalinity is because of the presence of the bicarbonates, the carbonates, and the hydroxides, and hence it is also called as the temporary hardness, is also called as the alkaline hardness. Now, the temporary hardness, as the name suggests, that the hardness is existing for a split second of time. If we in fact boil the water containing calcium bicarbonate or magnesium bicarbonate, then that type of hardness is removed because of the boiling, and hence the name is temporary hardness. So that means the hardness only exists till the time of boiling. So after boiling, the hardness is removed, and let us see the reactions that take place during the boiling of the hard water. So if calcium bicarbonate is present and we boil it, we are getting calcium carbonate, which is a white PPT, that is white precipitate of calcium carbonate is formed, and this calcium carbonate can be removed by filtration. Similarly, magnesium bicarbonate, when we are heating it, we are getting again another precipitate, that is magnesium hydroxide. So that means when we are boiling the hard water, and if we are getting some insoluble precipitates, and these insoluble precipitates are removed by filtration, so such type of hardness is removed because of boiling. Now, permanent hardness is that, as the name suggests, permanent means that when we are boiling the hard water, if the hardness is not removed, then we say it is permanent hardness. And it's because of the presence of the chlorides and sulfates of calcium and magnesium, and to some extent iron, the manganese, or the aluminium. So that means what are the salts which are responsible for permanent hardness? It is calcium chloride, then magnesium chloride, calcium sulfate, magnesium sulfate, ferrous sulfate, aluminum sulfate, etc. Now that means, as I said, it is not removed by boiling, and it is also known as the non-carbonate or the non-alkaline hardness. Now that means how are the permanent hardness removed from water? There are different processes that are involved that are operative because for the removal of permanent hardness. First is the lime soda process, second is the zeolite process, third is the ion exchange process, and fourth is the reverse osmosis process, and each such process will be dealt in details in our coming lectures. Now, total hardness is equal to temporary hardness plus permanent hardness. So that means there are two classifications of hard water. One is temporary hardness, the other is permanent hardness, and when we add these two, we are getting the total hardness. Now, what are the advantages and disadvantages of using hard water? The advantage is that the hard water, it obviously tastes better because of the presence of minerals, and minerals like the calcium and magnesium salts, and both calcium and magnesium salts, they are required for healthy bones and teeth and the proper functioning of the human body. So that means drinking hard water is beneficial for the human body. But then what are the disadvantages? That hard water, it causes the depressed cleansing and and for which more amount of soap is required for enhancing the cooking and enhancing the cleansing efficiency. Also, the hard water results in the consumption of more amount of fuel and more amount of energy and more amount of time, and these are the disadvantages of using hard water. Now, degree of hardness. Now, what do you mean by degree of hardness? Now, suppose I say our hard water is containing 1 milligram per liter of calcium chloride. Another hard water sample is containing 1 milligram per liter of calcium sulfate. So that means, how will we say that which hard water is more hard? So that means which salts are responsible for more hardness. So if we ever have to compare, then how will we compare such type of hardness? So there is a formula for this, that is, we have to convert all these salts, hardness producing salts, into calcium carbonate equivalent. Now, why we are selecting calcium carbonate as the standard? It is because calcium carbonate is first of all a very insoluble precipitate which can be removed easily from water by filtration, and also second point is because its molecular mass is 100, which makes the calculation easier. So now let us see, this is the formula for converting the hardness producing salt into calcium carbonate equivalent. So that means the calcium carbonate equivalent will be in terms of milligrams per liter or ppm. We very well know that 1 milligram per liter is equal to 1 ppm. So that means the strength of the hardness producing substance in milligrams per liter into the molecular weight of calcium carbonate divided by 2, whole divided by molecular weight of the hardness producing substance divided by 2. So this is the formula that we have to use if we have to convert a hardness producing salt into calcium carbonate equivalent. So that means this is one numerical. We have to compare the hardness produced by 1 milligram per liter of calcium chloride and 1 milligram per liter of calcium sulfate. So 1 milligram per liter of calcium chloride is equal to 1 milligram per liter into the molecular weight of calcium carbonate is 100 divided by 2, whole divided by molecular weight of calcium chloride divided by 2. So that means it is 111 divided by 2. So the result is 0.90 milligrams per liter. So how we have calculated the molecular weight of calcium chloride? It is the atomic weight of calcium, that is 40, atomic weight of chlorine, that is 35.5, and it is coming to a molecular weight of 111. So let us see how to convert the 1 milligram per liter of calcium sulfate to calcium carbonate equivalent. Now the formula used is again 1 milligram per liter into the molecular weight of calcium carbonate divided by 2, whole divided by molecular weight of calcium sulfate divided by 2. Now how we have calculated the molecular weight of calcium sulfate? The atomic weight of calcium is 40, the atomic weight of sulfur is 32, and the atomic weight of sulfur is 32 and the atomic weight of oxygen is 16. So it is coming to a figure of 136 and the result is 0.74 milligrams per liter. So that means we can say that the 1 milligram of calcium chloride is producing more amount of hardness as compared to the hardness produced by 1 milligram per liter of calcium sulfate. Now let us see what are the units of hardness. So there are 4 ways in which we can express hardness. First is the parts per million. Now it is defined as the parts by weight of calcium carbonate which is present in 1 million, that is 10 to the power 6 parts by weight of water. So that means 1 ppm is equal to 1 part of calcium carbonate equivalent in 10 to the power 6 parts by weight of water. Now second is the milligrams per liter. It is defined as the number of milligrams of calcium carbonate which is present in 1 liter of water. So that means 1 ppm is equal to 1 milligram per liter. Now third is the degree Clark. It is defined as the parts of calcium carbonate equivalent per 70,000 parts by weight of water. So 1 degree Clark is equal to 1 part of calcium carbonate per 70,000 parts by weight of water. Now fourth is the degree Frank. It is defined as the parts of calcium carbonate equivalent per 10 to the power 5 parts by weight of water. So 1 degree Franc is equal to 1 part by weight of calcium carbonate per 10 to the power 5 parts by weight of water. So what is the relationship between all these four units of hardness is 1 ppm is equal to 0.1 degree Franc is equal to 0.07 degree Clark is equal to 1 milligram per liter. So this relationship will be useful while deriving calculations. That means when we are going to solve the numericals, we will be taking the help of this relationship. So I hope you have understood this concepts. They are very important, and especially the numericals, we have to understand the formula as well as the units of hardness, and hope you have understood it. Thank you for listening.